This video is going to go over a couple of the problems from page 31 and then a couple of the problems from page 34. These were the only ones that were emailed to me, so if you have more questions, make sure you let me know. Okay, so on page 31, we're going to look at 4 and 6. So in number 4, the first thing that we have to do, of course, is to separate the variables. So we're going to multiply both sides by dx, but then we also have to divide by y. Now here's a case where you have a scalar of 3. Leave it away from what you are solving for. On this particular problem, I've seen it way too many times that people will put it on this side, and then for whatever reason, it seems silly, we'll forget to take out the 1/3, and then we'll forget that it's a U substitution problem if we don't take out the 1/3. Then we have to use crazy properties of logs to get y by itself. It just really gets much more difficult. So rule of thumb, if there is a scalar, always put it on the side that you're not solving for. So if you're solving for y, get it away from the y. So once I've done that, now I can integrate both sides. Okay, this one will be 3 ln, absolute value of 2 plus x plus c. Now again, the e and the ln have to be right next to each other before I can use a property. So this 3 is going to become the exponent, and then I can exponentiate. So I did that step, then exponentiated, so I have absolute value of y equals the absolute value of 2 plus x quantity cubed times e to the c, because remember, this means e to the ln absolute value of 2 plus x times e to the c. Okay, and then that becomes c, and we get our answer. Number 6, we want to change the y prime to dy dx, and then put the dx on the other side, so multiply by dx, but then divide by the quantity 1 plus 4x squared. We can't like subtract a 1, or it's just not going to work because that whole quantity is multiplied by dy dx. So we've got to get rid of the entire quantity. Now it becomes an arctangent problem where u is 4x or 2x, so du is 2 dx. So I balance with a 2 out in front, or 1/2, because I needed 2 inside, and then I can get my answer. Okay, on 34, we're going to look at number 6 and number 8. Okay, so 34, I just have to find my solutions for it. Okay, number 6. Okay, this one, an application problem, it gives us a number 6 that the bacteria has a double life. So normally you hear of half-life. A double life just means the time it takes for the amount of bacteria to double from its initial amount to a population of 4,539 in 40 days. Okay, so immediately I know in 40 days the population is 4,539. Now I don't know the original amount, but if I call the original amount C, double C would be 2C, and that occurs at 12 days. So I'm going to go to my exponential growth model, which we'll use for all of these half-life, double life, exponential functions are going to use this equation. I'm going to put in the 2C for y, C for the initial amount, at time 12. The C's will divide out, and I can solve for k. Now I want to store that value or keep it exact, so you don't want to round there and then round later on. Now I'm going to use the second initial condition, which was 40. At time 40, the population was 4,539, and I'm going to plug that in, and now I can find my C value. I have to do 4,539 divided by then this quantity, e to the ln of 2 times 40 over 12. While we're at it, number 7 was a half-life problem. And this one, what we get confused on is if they don't tell us the initial amount, then we think we can't do the problem. But let's say at time 0, there was an amount of C. If the half-life is 1,200 years, at time 1,200, it will be half of C. So into my equation, if I put c and 1/2 c, I can find the k value. Now what they wanted us to do is say when we dig up the kryptonite, there's going to be 10% as much as when it was buried. When it was buried, it was C. So 10% of C is going to equal C e to the k, and I'm going to put that value in exactly, times t. The c's will divide out, can ln both sides, and solve for t. And then the last one is, if you are a lifer at Stinky Burger and make $9 an hour in 2004 and get a raise to $10 in 2006 due to being named Captain Stinky, what is the rate of increase? Okay, so I'm going to call t equals 0 to make this problem a little bit easier. I'm going to say my starting point is in 2004, and that was $9. In 2006, which was 2 years later, so if 0 is 2004, 2 would have to be 2006, $10 was the rate. Okay, so the rate of increasing, assuming it's an exponential equation, we're going to put in 9 and 0, or 0, 9, y is 9, t is 0, and we'll get the c values 9. Then I'm going to put in the 2, 10, so 10 for y, 2 for t, divide both sides by 9, ln both sides, store the value. What is the rate of increase? If I change that to a percent, it's 5.268%. Now I'm storing it because there's a part B. What will your pay be in 2017 at the same rate of growth? So if 2004 was 0, 2017 is 13 years later. So t will be 13. So I'm going to do y equals 9, because we found that was the c value, e to the stored value of k times 13, and we'll get the amount. So I hope that helped you with those couple problems. If you have any other questions, let me know. Have a great weekend.